Okay, this is the remainder theorem. We're going to go ahead and evaluate each function at the given value. And remember, you can do it the old way, how you always done it, or you can do it, and we're going to go ahead and practice it with the remainder theorem, which is basically just synthetic division, looking at the remainder. So doing this one, you will be using, let's see, -1 for the x to the third. There's no x to the second. X to the first is a 6, and then -7 for no x's. We go ahead and do this with, and this already says x equals 2, so we're going to go ahead and just use 2. Right? So bring the -1 down, multiply, you get -2. Add it, you get -2. Multiply -2 and 2 together, you get -4. Add it, you get 2. Multiply 2 and 2 together, you get 4. And then add it, you get -3. And that right there, this is the remainder, which means that our original function, f evaluated at x equals 2 would give you -3. Okay, and we're going to go ahead and check that one really quick. Right, so you can do it the old way that you've learned in the lower math classes. You can literally just take the 2 and plug it into your x's. Right? So that's what I'm going to do on the calculator, just to double check, just to show you. Right? So you get a negative. You can put the 2 in there, so it'll be 2 squared to the third power plus 6, and then you're going to put a 2 in there, and then -7. Right? The answer comes out to be -3, just the same. Right? So on this assignment, though, on this practice assignment, we're going to be using the remainder theorem. So yes, you can do it that way as well, but we're going to be using the remainder theorem. So, right, so this one right here, we're going to go and use the remainder theorem. So 1 coefficient, -5, and -6. And we're going to use synthetic division with x equals 2. So 1, 2, 3, 6, 1, 3, and remainder of -3. So we're going to go ahead and say f right here. Right? F, if I put in 2, f of 2 equals -3. Wow, those are just very similar. Let me just check that one. I'm not even sure why, but let's see. So we're going to put in 2. Right? So 2 to the third power. So using that right there. Plus 2 to the square, bless me, -5 times 2, and then -6. Right, so all I'm doing there is just plugging in this 2 to all these x's right there, and right there. And you can see when I type on the calculator, it looks exactly the same. So 2 to the third plus 2 to the second minus 5 times 2 minus 6. Oh, that's -4. Okay, so that means I messed up somewhere. Let me go through this again. So that should be -4. You probably saw where I messed up. Let's look. So bring the 1 down. Multiply 1 and 2 makes 2. Add those, you get 3. Multiply 2 and 3, you get 6. You're going to add those, you're going to get 1. Oh, multiply 2 and 1. That's where I messed up. Well, multiply 2 times 1, you should get 2. And then it's -6, and +2 gives you -4. So the answer is -4. I think I was just trying to go a little too fast. Okay. So you guys can tell me if I'm wrong or if I messed up somewhere. Okay, I won't be checking with the calculator anymore. So we have 1, 3, 2, 8. Synthetic division or substitution, remainder theorem. A is -3. So bring the 1 down. Multiply that. you get negative 3. Add it, you get 0. Multiply it, you're going to get 0. Add it, you're going to get 2. Multiply it, you're going to get negative 6. You add it, you're going to get 2. That's your remainder. So we want to say f of negative 3, because we're using f, and the a is negative 3. So f of negative 3 is equal to 2. Okay, this one here, let's do it again. 1, 5, 10, 12. And use negative 2. Bring the 1 down. Multiply it out. 1 and negative 2 is negative 2. Add it. 3. Multiply it. Negative 6. Add it. 4. Multiply it. Negative 8. Add it. 4. So that's your remainder. So we want to say f of negative 2 equals 4. Okay, it's getting a little longer. So 1, 3, negative 17, 2, negative 7. And I'm going to use 3. So bring the 1 down. Multiply it, you get 3. Add it, you get 6. Multiply it, you get 18. So add it, we're going to get 1. Multiply it, you're going to get 3. Add it, you're going to get 5. Multiply it, you're going to get 15. Okay, and a negative 7 plus 15 is going to give you positive 8. That is your remainder. So your f of 3 is going to be 8. Okay, this one's a little even longer. So x to the 5th power. And you notice, right, as you look at it, you're missing x to the 4th power. So you can have 1. So x to the 4th power you're missing. X to the 3rd power is negative 47. X to the 2nd power is there, negative 16. And then x to the 1st power is there. No x's, 52. And use 7. So bring the 1 down, multiply it, you get 7. Add it, and you get 7. Multiply it, you get 49. Add it, you're going to get 2. Multiply it, you're going to get 14. Add it, you're going to get negative 2. Multiply it, you're going to get negative 14. Add it, you're going to get negative 6. Multiply it, you're going to get negative 42. Subtract that, you're going to get 10. That's your remainder. And so we're going to say f of 7, because we're using the f function and we're plugging in 7 for x, so f of 7 is going to equal 10. And I'm going to just check that one, just for the heck of it. Okay, so we have 7 to the 5th power minus 47 times x, which is 7 to the 4th power. Oh, actually, that's the 3rd power. Minus 16 times 7 to the 2nd power plus 8 times 7, and then that is plus 52. And that gets you 10, so that is correct. Okay, so that's just basically evaluation using the remainder theorem, using synthetic division. Okay, the rest of these we're going to use synthetic division, and we're going to figure out if these binomials are factors for the given polynomial. And by what we mean by factors is if it has a remainder of 0. So like if you look at all of these are not factors at all. Okay, so we'll see if that works. Okay, so we'll start 1, negative 1, negative 1, negative 2. We're going to go ahead and do synthetic division. That's k minus 2. So if we let it equal 0, like some of the previous things that we've done, we have to add 2. That means that the k is going to equal 2. Okay, we're actually solving for k. So we're going to use that. 1, 2, 1, 2, 1, and 2. And then that has a remainder of 0. So because of this, we would say yes. K minus 2 is a factor. Okay, next one we have 1, negative 8, negative 1, 62, negative 34. We're going to go ahead and do synthetic division with b minus 7, which means that b is actually equal to positive 7. So 1, multiply, you're going to get 7. Add it, you're going to get negative 1. Multiply, you're going to get negative 7. Add it, you're going to get negative 8. Multiply, you're going to get negative 7 times 8 is what, 56? Sometimes, yeah. You're going to add it. You're going to get 6. Sometimes 6 is 42. And whatever that is, it does not make 0. So this one, this one, okay, doesn't make 0, so that doesn't work. Okay, so I'm going to say no, b minus 7 is not a factor. Okay, so unless I mess up somewhere, but I think you guys can check it. So 1, 9, 14, 59, and do that with negative 8. So 1, negative 8, 1, negative 8, 6, negative 48, 2, 8 times 2 is negative 16. That doesn't work. Okay, so I'm going to say no, n plus 8 is not a factor. Okay, one more time. 1, 6, 11, 29, negative 13. And do this with negative 5. So bring the 1 down, multiply it, negative 5. Add it, 1, multiply it, negative 5. Add it is 6. Multiply it is negative 30. Add it is negative 1. Multiply is 5. And that, again, also does not work. So we're going to say no, p plus 5 is not a factor. So far, there's only one that works. Okay. Okay, so we're going to try this one. So 1, negative 8, 10, 2, 4, with negative 2. Positive 2. Because that was p minus 2. So when we solve for the p, we'll get positive 2. So 1, that's 2, negative 6, That's going to be negative 12. That's going to be negative 2. That's going to be negative 4. Be negative 2 and negative 4. This one, get a 0. So I'm going to say yes. Yes, p minus 2 is a factor. Okay, next one. Use 1. We don't have a 4. X to n to the 4 power, so we can use 0. N to the third, negative 25. N to the second, negative 7. Negative 37. Negative 18. Going to do this for n plus 5, which means we're going to use negative 5. Bring the 1 down, negative 5. Add it, you get negative 5. Negative 5 and negative 5 is positive 25. And add it, you get 0. You get negative 5. Oh, actually, 0 times 5 is... I'll just erase that. 0 times 5 is not negative 5. 0 times negative 5 is not negative 5. 0 times negative 5 is 0. Add it, negative 7. Add it, 35. Right. Add it, you get negative 2. Negative 5 and negative 2 is negative 10, which is negative 28, which is not a remainder of 0. So no, n plus 5 is not a factor. Okay. 1, 6, negative 3, negative 22, negative 29. You do this with x plus 6, which means we're going to use negative 6. Bring the 1 down, you get negative 6. That means you get a 0. When you multiply it, you're going to get a 0. You get negative 3. Multiply, you're going to get 18. And you get negative 4. Multiply, you're going to get 24. And that right there is going to get you negative 9 or negative 5, which is not a 0. So I'm going to say no, x plus 6 is not a factor. It's getting very laggy. Let me see. Okay, last one. That's 1, 10, 21, 6, negative 8. We'll do that synthetic division with negative 2. Bring the 1 down, multiply it out, negative 2. Add it, you're going to get 8. You need to multiply it, you're going to get negative 16. Add it, you're going to get 5. Multiply it, you're going to get negative 10. Add it, you get negative 4. Oh, this one comes out. Negative 4 and negative 2 makes 8. And you get a remainder of 0. So this one is yes. N plus 2 is a factor. Okay, so there's only 3 that works. Okay, so it was this one, 7 works, 9 works. Oops, sorry, 9 doesn't work. 11 works, and 14 works.